Myself, M. Nandhini, Assistant Professor, Department of Computer Science and Engineering, Data Science Department, Madanapalli Institute of Technology and Science.
In this lecture, we are going to see about the introduction to cryptography. Flow of presentation. Here we are going to discuss about the introduction, why cryptography is needed, classical versus modern cryptography, how cryptography works, types of cryptography, applications of cryptography, challenges in cryptography, types of ciphers. First, we will discuss what is meant by cryptography. Cryptography is the practice and study of technique for secure communication and information. For secure communication, we are using cryptography. Here we will use some codes and ciphers to transfer readable data and readable data into an unreadable format. Here we will use algorithms and keys to transform process. Codes and ciphers means here we will use some keys. Cipher means algorithm. Readable data means plain text. We are going to send the plain text to one more person. Plain text will converted into cipher text. Cipher text means unreadable format. Some primary goals are there. Ensures confidentiality. That means it will prevent unauthorized access. Only the authorized people can able to access that particular message. Then next, ensure integrity. It will prevent tampering or alteration of data. The next, verify authenticity. Authenticity ensures that the data is from a trusted resource only, not from the untrusted people. Then provide non-repudiation. It will prevent denial of sending or receiving data. Then finally, cryptography is essential that art of protecting information by making it readable only to authorized parties. Here cryptography, prefix crypto means hidden, graphy means writing. So hidden writing, if you want to send some message, sensitive information to one more person, means by using cryptography we can able to transfer the message without any deviation, without any properly we can able to send the information. Hackers can't able to hack the message what you are sending. So in the next slide we are going to see what is meant by plain text and ciphertext. Plain text means, as already in the last slide we've seen what is meant by plain text. Plain text means original readable data. That data will be the resource, that particular person will send that plain text message to the particular person with the help of some keys. Plaintext is the original readable data, while ciphertext is the encrypted form that is unreadable without decryption. Encryption and decryption. Encryption transforms plaintext into ciphertext using a cryptographic algorithm and a key, while decryption means reverse the process. Here encryption, we will transfer the plaintext into ciphertext. In decryption part, what we will do now, we will decrypt the ciphertext into plaintext. Key. Key is a unique piece of information that determines the output of a cryptographic algorithm. It's essentially for both encryption and decryption. Here we will be using some algorithms. That algorithms mean that is a mathematical procedure used in encryption, decryption and other cryptographic process also. Then why cryptography is needed? Why cryptography is needed means for protecting the data. With the vast amount of sensitive information nowadays in online, we are having more sensitive information that we need to store and we need to transmit it in the online. Cryptography is essential for protecting data from unauthorized access. Then for secure communication also, cryptography ensures that messages and data are only accessible by intended recipients and preventing eavesdropping or interception. So we need secure communication. Then authentication and identity verification. Cryptographic techniques verify that identities of user, allowing for secure logins, online transaction and digital digital signature. So authentication is very very important for each and every online transaction. Digital signature. Next, in data integrity, cryptography helps detect any tampering by ensuring data is unchanged from sender to receiver, which is critical in fields like banking and healthcare. Data integrity means what are all the data we are sending, we are having in that should not be altered. What are all the data we need, we can able to store that, we can able to access that particular information without any changes, without any modification. Next, classical versus modern cryptography. Two types of cryptography, that means classical is there, modern also there. Classical cryptography involves basic techniques like substitution and transposition cipher used in historical methods like Caesar cipher, Playfair cipher, Vinegar cipher. So classical cryptography, it is very easy to implement by substituting each and every alphabets like that. Whereas in modern cryptography, advanced methods are used, often based on complex mathematical algorithm. Algorithm. There are so many algorithms are there. Basically, we are having two algorithms: RSA algorithm and AES algorithm. RSA means reverse Scheimer adultment algorithm. Then advanced encryption standard algorithm. Modern cryptography is used in digital security, online transactions, and digital signature. Key difference. Here we'll be using some key. What's the difference in that we will see now. Classical cryptography is often easier to break because it relies on simpler method, while modern cryptography is more secure, suited for the complex requirement of digital communication. How cryptography works? Let us see this diagram. Here on side we are having sender, then one more side receiver is there. If sender want to send some message to that particular receiver, what that how they will send means, first sender will send the plain text to the encryption server. In encryption server, what will happens means, that sender will use some encryption key. With the help of encryption key, that plain text will be converted into the ciphertext. Then once converted, it will be sent to the network. Then in receiver side, what receiver will do means, that in decryption server, that receiver will use some decryption key, then the ciphertext will be converted into the plain text. So then finally, that what sender send means, that final text will be, final text can be easily, the receiver can able to read, but in between we are using ciphertext. Ciphertext means, in the beginning we discussed, ciphertext means unreadable data. Cipher and cryptography are same only. Types of cryptography. Here we are having two types of cryptography. How we are telling two types of cryptography means, based on the key we are telling two types of cryptography. One is symmetric key, one is asymmetric key. In symmetric key, we will be sharing the same secret key to the sender and the receivers. That means sender and the receiver will share the same secret key. When each party, that means sender and receiver, uses the same key to encrypt and decrypt data, that means here they mentioned one algorithm, AES algorithm and DES algorithm. Okay, here server sender is there, sender is going to send one sensitive information to the receiver, but in between hackers will be there. So if you, without any encryption decryption, if we send the data, I mean, hackers can able to easily read that data. Sender will encrypt the data with the help of some encrypt server. So that plain text will be encrypted with the help of some key. Some key means they are sharing the same key. So after encryption, the plain text will be converted into the cipher text. Then in decryption side, what that decryption will do now? They in decryption side, they will use the same key for decrypting the data. Yeah, so after decrypting, that ciphertext is converted into the plain text. So that plain text is in readable format. So what the sender send means that receiver can able to read that particular data. So they are sending the data securely without the third person can't able to read that particular data by using the same shared secret key. This is symmetric. Whereas in asymmetric, uses a pair of key, a public key for encryption and a private key for decryption. This method is more secure but computationally intensive. Here in our symmetry key we used same key for encryption and decryption, whereas in asymmetry key here we will be using public key and private key. That public key and private key belongs to the receiver side. So the receiver will share the public key to the sender. What sender will do now? Sender will send the prior plain text to the encryption part. In encryption server, what will happen means by using the public key, they will encrypt the data. Once encrypted means we will receive the ciphertext. Then ciphertext will be the input of decryption server. In decrypt side, what will happen means the receiver will use the private key. By using the private key of receiver, he will decrypt the message. Once decrypted means that receiver can able to read the plain text. So here we are using two keys. One is public key, one is private key. Public key means it will be visible to everyone. Private key means only that particular person will be having that key. Next, applications of cryptography. First one, internet security. Cryptography secure protocols like HTTPS and SSL, ensuring safe browsing and data transmission online. Next, banking and finance, used in securing transaction, online bankings and ATMs. Next, healthcare, protect sensitive patient information and electronic medical records. Blockchain and cryptocurrency. Cryptography secure blockchain transaction, ensuring trust and transparency in decentralized system. Government and military, used for secure communication and protecting classified information. What are all the challenges in cryptography? There are so many challenges in cryptography. Recently, quantum computing is emerging. So, quantum computers could break many current cryptographic systems, creating a need for quantum resistant cryptography. Key management. Securely distributing and managing cryptographic keys remains a complex challenge. Computational requirement. Cryptographic algorithms can be resource intensive, impacting performance, especially for mobile devices or IoT systems. Vulnerabilities and attacks. Cryptography system can still be vulnerable to attacks such as brute force, side channel, and cryptanalysis, requiring constant advancement in cryptographic techniques. Types of cipher. In types of cipher, we are having four types of cipher. First is substitution cipher, transposition cipher, block cipher, stream cipher. First, we will discuss what is meant by substitution cipher. Each letter or symbol in the plain text is replaced by another letter or symbol. Example, Caesar cipher, Playfair cipher, like that. How we are telling each letter or symbol in the plain text is replaced. For example, let us consider cipher, CIPHERS. There are two types, shift cipher and normal cipher. For shift cipher, we will use number 3. For normal cipher, we can use any other numbers. We will discuss this one in next video. Transposition cipher. The the position of the characters in the plain text or shift or rearranged. Example, railfen cipher, columnar transposition cipher. Here we are having 4 rules. By using the 4 rules, we will change the position. In substitution cipher, just we will change the letters or symbol. But here we will change the position of the characters. Next, block cipher. Block cipher operates on fixed size of blocks at a time. Example, advanced encryption standard, data encryption standard. Stream cipher, encryption data one bit or byte at a time. In block cipher, we will consider a plain text as block by block, whereas in stream cipher, one bit at a time or else byte at a time, making it suitable for real-time encryption. Example, RC4 algorithms. Then what's the difference between block cipher and stream cipher? This encryption types converts plain text one block at a time, whereas in stream cipher converts plain text one byte at a time. It it employs both diffusion and confusion principles in conversation, whereas in stream cipher it utilizes the confusion principle. Block cipher converts one blocks or plain text at a time. In stream cipher, it will convert minimum of 8 bits at a time. Whereas while compared to implementation, block cipher is primarily implemented in the physical cipher, whereas stream cipher is mainly implemented in the Vernam cipher. Then complexity. Block cipher is relatively simpler structure and design. Stream cipher has more complex and design. Speed. While compared to speed, block cipher operates slower compared to stream cipher, whereas stream cipher works as faster as block cipher. These are all the references I used to prepare this video. Thank you for giving this wonderful opportunity.